Welcome back to the Tuesday, taking a look at coordinate geometry with squares. So with squares, we have to actually do two shapes, okay? So we need to do both a rhombus and a rectangle. So our job is either to show that all the sides are equal using the distance, and then two of the consecutive sides have opposite reciprocal slopes, or we can show that it is a rectangle first by using the slopes to get right angles, and then show it's a rhombus by showing consecutive sides, two consecutive sides congruent. We can also do this method, which is to do a parallelogram first, get one right angle, and then two sides that are touching to be congruent. So the normal way I would advise is to just pick either all the distances to be the same, and then two slopes to show their opposite reciprocals, or do all the slopes first and then do two distances to show that they're equal. The distances to show equal, all sides equal, have to be the sides that are next to each other, A, B, B, C, okay, or B, C, C, D, to make sure we're going through and doing that. All right, so let's take a look at number one. I've already graphed it, okay, for myself. So we're gonna go ahead and do the four slopes, okay? So we're gonna do the slope of AB. Okay, once again, it's y2, so it's 3 minus y1, which is -1, and then 3 for x. Oh, we did that backwards. 3 for y minus 0, which is the y coordinate, and then the x's. 3 minus -1. And so this turns into 3 over 4, so plus positive. Now the next slope, AB, BC, is supposed to be perpendicular. So we know if this is 3/4, the other one should be -4 over 3. We're already keeping that in mind. So the slope of BC here is y2, coming from C, is -1, minus the y1, which is 3, over x2, which is 6, minus 3. And here we get -4 on the top, positive 3 on the bottom, and look at that. We got opposite reciprocals. Okay, we're going to go to the next one, which is DC. Now this should be the same as AB, so we'll put it right underneath because we know it's supposed to be the same. All right, so DC, we're going for y2, which is the y coordinate, so that's -4. Clean up that 4 a little bit here. Minus y1, which is -1. There's a plus positive. And then x2 is 2 minus x1, which is 6. And this comes out to be -3 over -4, which is positive 3/4, since both of those numbers are negative. And then we have to do the last slope, which is AD. Okay. All right, and we're going to go ahead and do that slope as well. So D, we're going to choose that as y2, so that's -4 minus A for y is 0. And then D, the x2 is 2 minus the x1, which is -1. This comes out to be -4 over positive 3. All right. So we have AB and DC have the same slope. BC and AD have the same slope. And we can see that AB, BC, DC, and AD, these all have opposite reciprocals here. So we're good to go. So what we're going to do is we're going to go ahead and make a statement underneath and say that ABCD is a rectangle since consecutive sides are perpendicular. Okay. And then we're going to put down the reason we know that, which is slopes are opposite reciprocals. All right. Now we have to do the fact that it's a square. So we have to show that two sides are the same length. So we're just going to pick AB and BC. So we'll do the distance for one. We'll do Pythagorean theorem for the other. So the distance, we're going to make that a normal size line. And we'll do AB for this one. Okay, so once again, that's x2 minus x1. So x2 is 3 minus x1, which is -1. That becomes 3 minus -1, and 3 plus 1 squared. plus y2, which is 3, minus y1, which is 0 squared. Okay, and so the distance of AB is going to turn into 4 squared plus 3 squared. And we do the math here, that's going to be 25. And so this becomes 5. All right. And then we're going to do the same thing for BC. This time we're going to use the slopes. We're going to use the rise and the run. So we can count that this is plus 3. This is going to go negative 4. And so we're going to do a squared plus b squared equals c squared. So 3 squared plus negative 4 squared equals c squared. 25 is equal to c squared, and then square root to get 5. All right, and so we're going to say the distance of BC is equal to 5. All right, so now we're good to go. So now we can say that we can do a little statement underneath. AB congruent to BC. Okay, distances are equal. All right, and then we're going to make our summary statement underneath. So we're going to say ABCD is a square since it is a rectangle. Remember, we already said it was a rectangle, and has consecutive or adjacent sides that are congruent. All right, that's it. And if you want to make this a little bit, you can do that for it. It's up to you. And there is there you go. We're all done. All right. Going down to number 2. So our job here is to show that this is a rhombus, not a square. So we're going to do the distances first. Now the good news is 2 of the distances are horizontal lines. We don't have to do any work for them. We can just count. The other 2, we do need to do some work for them. So we're going to do the same thing. We'll do distance formula for AM, slope for TH, do Pythagorean theorem, and we'll go from there. So the distance of AM equals square root. Remember x2 first. So x2 is negative, well, I'm going to switch this AM around, and I'm going to write it the way it appears. So I'm going to do MA. Okay, I like to keep this organized with the first point going first, and the second point going second. Why is this switching colors on me? All right, so distance of MA. So negative 2 for x2 minus x1, which is negative 1 squared, plus y2, which is 5, minus y1, which is 1 squared. All right, so this is equal to square root. So negative 2 minus 1 is negative 3 squared, plus 5 minus 1 is 4 squared. This, once again, is going to equal 25. And so this is 5. And this is the distance of MA. Okay. The next one we're going to do is TH. We're going to go ahead and use our slopes. So you can see we're going to use positive 3 again, and then going down 4, which is negative 4. The other one would have been using negative 4 and positive 3. So you can see like this is using the exact same slopes, all right, for both. So we're going to go ahead and do a squared plus b squared equals c squared. We're going to plug in the 3 squared plus negative 4 squared. That's 25. And then the square root to get 5. Now, had I done the slope formula, the rise and the run for Pythagorean theorem for both, I would just underneath make sure that I indicate the distance of TH equals 5, and then I would put down the distance of MA equals 5. So I'm specifically telling you what work that is for. Okay? All right. Now, we also know the distance of AT, we can just count, is 1, 2, 3, 4, 5, and the distance of MH, 1, 2, 3, 4, 5. So I'm just going to make those as well. The distance of AT is 5, and the distance of MH is 5. Okay, so now we have enough. We can go ahead and make our statements. Now we can make one quick statement, but we'll write a summary statement just for the first part. We're going to say MATH is a rhombus since all sides are equal. And the reason we know that is because the distances are this equal. And actually, I'm going to change the first equal there to congruent because we're using some geometry language here. Now, I could have also put a little statement here that says TH is congruent to MA, is congruent to AT, is congruent to MH, and then just not have to put this part. So somewhere along the line, I want to make sure we say that those are congruent, distances are equal, and then it's a rhombus because all sides are congruent. So there we go for the first part. Now we got to do it's not a square. So if it's a rhombus, the reason it would become a square is that we have a right angle. So we're going to do the slopes for 2 consecutive sides and show that they're not the same. Okay, sorry, not that they're not the same. They're not opposite reciprocals. Okay, so we're going to do the slope. We'll just pick any side. We'll go AT. Okay, now AT we already know is a horizontal line. It's supposed to be 0. We're going to go ahead and just use our formula just because we're doing a little review. But I could say 8 equals 0, and actually we will. It's a horizontal line. Okay, nice and easy. Vertical lines undefined, horizontal lines are 0. If you wanted to and you don't think you do that on your own, feel free to just plug in the points, right? So 5 minus 5 over 3 minus negative 2 is going to give you 0 over 5, which is equal to 0. And then the other line we're going to choose is we'll choose TH. It's either going to be AM or TH here. It's got to be touching. All right. So TH is going to be Y2, which is 1, minus Y1, which is 5. Remember, T is coming from Y2 is coming from the H, Y1 is coming from the T, and then X2 is going to be 6 minus X1, which is 3, and so this is going to equal negative 4 over 3. And we already know that because we literally wrote out the rise and the run. Negative 4 for the rise and then negative 3 for the run. So we're good to go. We could also just use that to help us out here. And then we got enough. So now we're going to say MATH is not a square. MATH is not a square since consecutive sides are not perpendicular, right? And the reason for that is that the slopes are not negative reciprocals. If you want to say opposite reciprocals instead of negative reciprocals, feel free. And that is it, guys. So hopefully you guys picked up on the square part, rhombus, the rectangle. Tomorrow, taking a look at trapezoids. Have yourselves a great day.